Samar Island is the third largest island in the Philippines and has one of the most extensive forest over limestone ecosystems in the country. This ecosystem is home to a wide array of uniquely adapted flora and fauna. Samar Island is known to be one of the centers of botanical diversity in the Philippines and has been nominated as a UNESCO World Natural Heritage Site for its exceptional natural beauty and precious biodiversity. For these reasons, CONserve-KAIGANGAN, a biodiversity research program, was established. Kaigangan is a Samar local word that means forest over limestone. Our research program's mission is to assess and conserve the biodiversity in Samar Island's forest over limestone towards its sustainable management. One of our program's projects is the assessment of biodiversity and community structure in forest over limestone ecosystems. This component of our research aims to determine plant diversity and vegetation structure in various habitat types in forests over limestone, to determine animal diversity associated with forest over limestone, to identify functional classification of vegetation with its associated animal diversity, and to analyze the environmental factors influencing the prevailing structure of the biota. We conducted a comprehensive biodiversity assessment of forests over limestone in the municipalities of Paranas, Taft, and Giwan with remarkable findings. A combined total of 71 plant species were recorded from these municipalities, with at least 3 tree species classified as vulnerable based on the DENR updated national list of threatened Philippine plants. A total of 52 terrestrial vertebrate animal species were also recorded, including 5 amphibian species, 15 reptile species, 20 bird species, and 12 mammal species with conservation statuses ranging from threatened to endangered and critically endangered, based on the DENR updated national list of threatened Philippine fauna. This knowledge will empower our stakeholders in these areas to make appropriate research-based conservation efforts for the protection of these ecosystems that harbor an assemblage of rare, endemic, and economically important flora and fauna. Through this program, people will be equipped with knowledge on forests over limestone biodiversity, including the ecosystem services that it can offer to the community. We at CONserve-KAIGANGAN continue to further raise awareness and capacitate national and local government agencies, especially local communities living in and around Samar's Kaigangan.
Hello everyone, welcome to Kaigangan Biodiversity Webinar Series. In March 2022, Ms. Elaine presented about the biodiversity of forests over limestone in Samar Island Natural Park, or also known as the SINP. Her study aimed to provide information on the outcomes of the plant and animal biodiversity in SINP. Second, to describe the tree community structure in SINP. Third, to highlight the significance of the nomination of SINP as a UNESCO Natural Heritage Site. This was conducted specifically in Paranas and Taf, Eastern Samar, a province in the Philippines located in the Eastern Visayas region. Some of the highlight of the results of her study are the identification of some ecologically important amphibians, for example, the Philippine endemic Platymantis guentheri. In terms of reptiles, a very interesting one example is the Lycodon dumerili, which exhibits a widespread distribution and has been documented throughout the Mindanao Paig, or the Pleistocene Aggregate Island Complex. Ms. Elaine discusses also about her interesting findings on birds, for example, the Bucerus hydrocorax semigaleatus, also known as the Philippine hornbill, a large species of hornbill endemic to the Philippines. In terms of flora, she found this new island record species, for example, the Tectaria calcarea, a fern or herb species with native range in the Philippines. Overall, Ms. Elaine emphasized that SINP is indeed worthy of its nomination as a UNESCO Natural Heritage Site because of its natural and cultural significance. The following month, Ms. Ren D. Obenya successfully presented a very good study on some threatened woody plant species of forest over limestone in the Philippine Islands. The study determined the threatened woody plant species in the forest over limestone in the Philippines and discussed the threats of the forest over limestone in the country. And of course, Samar Island is one of her study sites in addition to Cebu and Batangas sites. Ms. Ren presented the list of critically endangered species based on the Philippine DO Red List and the IUCN Red List. She also made an emphasis on economic uses of some of the identified threatened woody plant species in her study sites, for example, the Shirrea nigrocensis, a Philippine endemic dipterocarp species, and our very own Tectona philippinensis with known natural populations in Batangas and in Mindoro. The third one is the Aquilaria cumingiana, a source of agarwood, a highly prized resin with many economic values. And the fourth example is the Hopea philippinensis, which is also a Philippine endemic dipterocarp species. Part of the study is the identification of threats and conservation concerns in the study site. For example, the limestone quarrying, deforestation, illegal logging, among others. Ms. Ren concluded the presentation by highlighting the potential contribution of her study to sustainable development goals. The pattern of plant distribution with reference to ecological parameters using multivariate tools in Paranas, Taf, and Iwan, Samar. Assistant Professor Marjorie recorded 26 understory floral species divided into 21 flowering species and 6 fern species. Part of her study is to determine the species richness and diversity indices of Paranas, Taf, and Kiwan. In addition, she found that the understory plant species from Paranas and Taf sites are highly affected by soil iron concentration and electrical conductivity, whereas plants from Giwan are highly associated with soil pH and other macro and micronutrients.
Yan. Good morning, everyone. Welcome to our 8th Kaigangan Biodiversity Webinar Series. And I'm Lani. Again, I will be your host. Ayan. Good morning po. Kamusta po ang lahat? Please feel free to greet everyone in our chat box po. Introduce yourselves, your affiliation, and where you are right now so I can recognize you po. I will read some Yung mga nag-chat na po, ay ayan. Good morning po, Dr. Jabez, our speaker. Good morning po. Good morning po, Miss Kai.
Good morning.
Ayan. Miss Kai from UPLB, ayan. Good morning po, Miss Hazel Grace Villaruel. Parang ating suki, si Miss Rachel, Hazel. Good morning din po, Ma'am Melissa Antonio. Ayan. Good morning, Sir Jamil of UPLB. I see familiar faces din po. Good morning din po sa ating project leader. Good morning po, Dr. Hilario. Sino pa ba? Ayan. Good morning po, Sir Mike Sanchez. Yung mga kilala ko. Good morning po. Sino pa to? Sir Francis Aguilar. Ayan. Good morning po. Good morning, Sir Aaron Balo-Balo. Ayan. Good morning, everyone. Sana po ay okay ang inyong umaga. Nasa mode pa po ba ng bakasyon? Ayan. So, ayan. Magandang umaga, Sir Mike. So, before we start, ask ko lang po sino po ba dito yung naka-attend dun sa ating last webinar, which is from Dr. Humawan. This is about the a bibliometric analysis of the research trends and directions in Kaigangan. So we hope ay nag-enjoy po kayo and natuto ng marami katulad namin. So for today's webinar, so again, welcome po to CONserve-KAIGANGAN webinar series. So this sessions happens twice a month, once or twice a month. So please stay tuned to our FB page. So before we begin, I know all of us are excited, but we want to remind everyone that this webinar is recorded. So with this, please take note of the following rules for our decorum. So first, kindly keep your microphones muted, especially when our speaker is presenting. Second, if you have questions or clarifications, please type them in our chat box and we will acknowledge them during our open forum. So the link to the evaluation form will be provided and e-certificates will be sent after completing the evaluation form. So please make sure that the email address you indicate are valid and correct, as it will be used to send the e-certificates. Ayan, now that we've set some ground rules, we can now continue with our event. So before we call our guest speaker, let me first introduce him. Our guest speaker is a graduate of Bachelor of Arts in Sociology in UP Los Baños, Master of Environment and Natural Resources Management, major in Upland Resources Management in UP Open University, and Doctor of Philosophy in Environmental Science with a cognate in Development Communication in UPLB. So he was a DOST Sci Graduate Scholar and a CIRCA PhD Research Scholar. He is an associate member of the National Research Council of the Philippines and a member of the International Association for Landscape Ecology, Europe. His research interests include agroecology, landscape ecology, GIS and drone photography, network science, and environmental communication. So a licensed drone pilot, he currently works full-time as a freelance environmental consultant while teaching part-time as a senior lecturer at UP Open University. So ladies and gentlemen, without further ado, let's all welcome Dr. Jabez Joshua M. Flores to talk about drone mapping, potential applications of GeoNadir environmental drone mapping software in forest over limestone research.
Good morning. My name is Jabez Flores. I am a senior lecturer for UP Open University and an environmental consultant and drone pilot. Today, I will introduce to you GeoNadir and the concept of drone mapping and how we can use this for the conservation of forests over limestone in the Philippines. Like my previous lectures and workshops on drones and drone mapping, I will start the discussion by introducing you to the world of drones. And then I will show you some tools for analysis, how to analyze images qualitatively and quantitatively. And then I will introduce to you GeoNadir, the online software that I am currently using. And lastly, I will present some applications of these technologies in forest over limestone research. An unmanned aerial vehicle, or UAV, is an aircraft that is operated without a human pilot on board. They can be remotely controlled manually or flown autonomously using pre-programmed flight plans. A drone is a general term for UAV. It refers to remotely controlled vehicles on land, water, or air. The term is mostly used for UAVs. The recent emergence of commercial UAVs or drones in the market has led to the widespread use in the film, events, tourism, and real estate industries. In agriculture and the natural sciences, drones are used by farmers and scientists for the purposes of mapping, monitoring, landscape planning and management, and application of fertilizers. The use of commercial drones in research methodologies and mapping workflows can provide students and researchers with a unique perspective of the world that was not possible a few years ago. In this era of climate change, we need to map and monitor a lot of things because conditions on our planet are changing at a rapid pace. With drones, planning, decision support, and on-demand data collection in inaccessible and large areas are made possible with the aid of aerial imagery captured by a single drone pilot. Along with smartphones, laptops, and digital cameras, drones should now be an essential tool for research. And if you want to have a license, you should enroll in a drone school. Drones can be used in many ways. Military forces have been using drones since World War I for surveillance and reconnaissance missions. The popular use of UAVs began in the 2000s when it was made commercially available by companies such as DJI. Applying UAV technology in agriculture is seen as a solution to optimizing farm production and in addressing food security. Drones are also used for delivering supplies. Drones have different cameras or sensors that collect data and detect objects on the ground. For commercial drones, we typically have RGB sensors or our usual cameras that can see visible light. And we also have special cameras with powerful sensors that can detect heat, like the thermal camera, can determine elevation, like the LiDAR, or detect diseases in plants, like the multispectral and hyperspectral cameras. Some uses in research include the following: site survey, planning and design, land use and land cover monitoring, surveillance, disaster response, health and epidemiology, science communication, and ecotourism and agri-tourism. Aside from aerial images, drones can also produce specific data products such as orthomosaics, georeferenced 2D and 3D maps, 3D models, drone observations record, and digital terrain and digital surface models. To help us analyze these data products, we can use qualitative and quantitative tools. A guided aerial visual assessment is a qualitative tool to analyze drone images over a long period of time. This is a drone image taken by the DJI Rise Tello at 10 meters. What landscape elements can you see here? These are some elements identified just by looking at the photo. We can quantify this information using this table. Now we have baseline data derived from a single drone image. The guided visual assessment helps us identify what to look for. Now let me introduce you to GeoNadir. GeoNadir helps us address multiple challenges with drone data: storage and management, processing, analysis, and collaboration. GeoNadir can store both public and private datasets. It operates using the FAIR principles of findability, accessibility, interoperability, and reusability. Researchers can download public datasets for free and use them for their own researches. Here is an example of a dataset in Indonesia. This is a permaculture farm we studied for a project. The dataset is also accessible to the owners of the farm and to those who want to study permaculture. Now let's take a deep dive into how to use drones in our topic of interest, which are forests over limestone. Based on GeoNadir's Fair Global Map, we only have a few public datasets available in the country, and none in Samar, Northern Samar, or Eastern Samar as of this webinar. Due to this limitation, we will use a proxy dataset for our demonstration, one that also has a high density of trees similar to a forest over limestone. I chose a dataset in Sagada and Tayabas as candidates for analysis. The Sagada dataset was collected by Malvin Figueras, while the Tayabas dataset was collected by myself and Ben Francia, the owner of the permaculture site in Tayabas called Habilin Farms. I need a high-resolution dataset for this demo, so I checked the ground sampling distance, or GSD, of each dataset. GSD is the distance between the center of two pixels. You can find this information embedded in each dataset available in GeoNadir, as seen on the slide. The Sagada dataset has a GSD of 3.56 centimeters, while the Tayabas dataset has a GSD of 1.45 centimeters. I chose the smaller value so it can give me the highest spatial resolution. Therefore, I will use the Tayabas dataset as proxy data for the remainder of this webinar. This dataset contains 687 individual images taken at an average altitude of 53 meters. These images were uploaded in GeoNadir and took around 2 hours to process the data. Processing involves uploading, storing in the cloud, stitching the images, georeferencing and overlaying the final orthomosaic on a satellite image, and extracting elevation data. This is all done automatically by GeoNadir without installing anything in your computer or saving images on your hard drive. The processing produced two types of digital elevation models: the Digital Surface Model, or DSM, and the Digital Terrain Model, or DTM. The DSM includes the landscape elements on the surface, while the DTM removes those and only considers the ground in the visualization. This is called a Viridis color palette, where the lighter colors indicate high elevations, while the darker colors indicate low elevations. Using these models, we can visualize the heights of individual trees. In the GeoNadir project workspace, we can import other vector data layers as well, such as contour lines, boundaries, waypoints, and GPS tracks over the orthomosaic, or DEM. In addition to vectors, we can also add geotagged ground photos or aerial photos to provide more context in our orthomosaics. We can take photos of individual trees at the ground level and see them in the context of a map using the Inspect tool. You can see the photo icon geotagged on the exact location where the photo was taken. This can be helpful for plant inventory studies. I tried this method in UPOU to locate the edges of a boundary from a vector file. Using the Google Earth app and GPS Map camera app, I was able to take a geotagged photo and upload it to GeoNadir. This is how aerial and ground photos can help each other. I got this idea for extracting tree growth data from a mapping mission in the Amazon rainforest using Pix4D Matic. Using the DSM, we can see mature trees, grassland, soil, and built structures. Using the Enhanced Contrast tool of GeoNadir, these features can easily pop up, and then we can classify these areas using the AI-powered Magic Wand tool that auto-segments landscape features. Using this technique, we can find disturbances within the forest over limestone, while monitoring tree growth. If we want to extract the height of individual trees in the forest, we can use the height calculator tool and inspect tool. When we use the height calculator, a height layer will be created. Then by clicking on an individual tree, we can see the coordinates and the height in meters. This tree is estimated to be 15.42 meters in height. Using the DSM, we can also estimate the crown diameter of each tree. The Enhanced Contrast tool and the Magic Wand tool makes it easier for the user to digitize the object of interest. Once segmented, GeoNadir provides an instant measurement. This tree has an estimated crown diameter of 10.52 square meters. For analysis, we can use the Compare tool in two ways. First, in this example, we are comparing a drone dataset with a satellite image base map. By swiping, we can see the difference between the resolution of the two images and the spatio-temporal changes that occurred. Second, we can also compare spatio-temporal changes between two drone datasets. This is an example in UPOU comparing a grassland in May 27, 2024 and in October 7, 2024. The more recent dataset shows greener vegetation. Second, we can also compare. Another way to analyze a forest dataset is to use the Greenness Index or GI. This tool can be used to determine vegetation vigor in the forest. This index is different from the more well-known NDVI or Normalized Difference Vegetation Index. An expensive multispectral camera is needed to collect the necessary bands to compute this index. However, when a multispectral camera is not available, we can use the RGB sensors of a commercial drone to capture the GI instead. This can provide proxy data for initial assessment of vegetation health based on visible light bands. Lastly, using the Inspect tool, we can view the value of each pixel. The Change Detection tool can give us a visualization of two different drone datasets. The change detection can either be based on the Greenness Index for vegetation, digital surface model, or digital terrain model. Using this method, we can instantly see which areas on the landscape underwent significant change over time. Darker colors indicate more change, while lighter colors indicate less or no change at all. We can also do segmentation and classification using GeoNadir. I selected a specific area in the Tayabas dataset where there are visible differences on the landscape. Using the Magic Wand tool, I collected samples or training data of the regions of interest. In this example, I collected samples of bare soil, vegetation, and built-up or man-made structures. The Magic Wand tool will instantly segment these areas and provide corresponding measurements of each in square meters. The colors are manually chosen, but you can choose the appropriate hex code for each depending on how you want to classify your study area. The drone can also capture very high resolution images depending on the flight altitude and the objective of your research. If you want to identify trees in the forest, you can fly the drone at a lower altitude and then you can zoom into the leaves once you process the orthomosaic. Using the Inspect tool, you can determine the coordinates of these leaves and even digitize them if needed in your GIS workflow. Some advantages of drone data include the frequency of data collection. It can either be daily, weekly, monthly, or quarterly. High resolution cloudless aerial images, access to open and fair data, and multiple drone pilots can collect data. While some disadvantages include it covers a relatively smaller area compared to satellites, investment in drone pilot training for safety and to avoid flight risks, and drones cannot be operated in bad weather conditions. And these are the advantages of using GeoNadir in mapping plants in a forest over limestone. It can be used to detect anthropogenic activities such as quarrying, land conversion, deforestation, increase in human settlements, etc. It can be used to inspect post-disaster damage such as fallen trees, erosion, flooding, burnt landscape, etc. It can be used to validate plant spatial distribution models. It can improve visualization of base maps and changes over time. And all data can be exported to QGIS and other GIS software. This paper is my reference for the webinar. And thank you for listening, and please join our FB group, Drones for Research, if you want to learn more. I will see you again in the Q&A portion of this webinar. Goodbye.
Yan, thank you very much,
Good morning.
Dr. Jabez. Ayan, I hope we know that our participants learned a lot from this, from your talk. So may I invite everyone to our open forum. So please kindly chat your questions in our chat box, and I will read it for you. So while you are doing so, sir, I have questions here from our pre-registration. So first question, sir. Ayan. So, nabanggit nyo na naman po, sabi niya kasi dito, what is a GeoNadir environmental drone mapping software? So, if you want to elaborate, okay lang din po. And follow up, is it applicable to all forest types or formations? And will it determine or identify the indicators of forest over limestone?
Ayan, thank you for the question. Yung GeoNadir, punta lang kayo sa www.geonadir.com. And also, meron din siyang paid version. So, depende yan kung ano yung features na kailangan nyo, ano yung needs ng research nyo. So, pwede kumuha yung individual, pwede kumuha yung isang project. And naman talaga yung GeoNadir, just like us. So, ang target niya is ecosystems. Okay, so, meron tayong mga specific tools, katulad ng mga pinresent ko kanina, na para ma-serve yung ating mga purposes. No? For example, identifying plants, although hindi na ma-identify kung anong klaseng plant yun, makikita mo visually yung differences ng bawat halaman from above. Meron mga techniques sila na tinuturo, no, paano mag-distinguish between different vegetations. Pero ibang workshop na yon. Kaya maraming halos every other week nagre-release sila ng bagong features kasi very receptive sila sa input ng ating mga users. Kasi based po yung founders nitong GeoNadir sa James Cook University, ang kanilang nire-research naman ay yung Great Barrier Reef. So, coral bleaching naman po yung kanilang inaaral. So, applicable siya sa lahat ng ecosystem. So, visit na po kayo dun sa website at pwede na kayo mag-explore. No need for password. You just need email. Tapos meron silang i-email sa'yo na verification code. Tapos yun na yung gagamitin niyo.
Hope nasagot ang question. For the next question po, this is from Dr. De Los Angeles of UPLB. Sabi niya, Dr. Flores, I was wondering what file format does GeoNadir drone images come in TIFF? TIFF is to raster for quantitative data extraction.
Yes. So, thank you for the question. Pag nag-upload tayo ng data sa GeoNadir, it can be in JPEG or raw file, no? Yun yung extension. Tapos pag i-import na natin siya to a GIS software, pwede yung TIFF na file. So kahit lahat ng format ng raster kaya niyang i-import, no? So para magamit natin sa ating mga GIS, ArcGIS, QGIS. Meron din siyang feature na tinatawag streaming. So merong TMS link, pwede mo i-stream yung base map mo doon sa QGIS mo. So para hindi mo na siya i-download. Yes.
Thank you, sir, for that. Ayan, wala na ba sa chat box? Meron pa po ako, sir, dito. Can you suggest drone mapping techniques for underwater flora and what drones are applicable? Thank you.
Thank you for that question. Meron akong nakitang dataset sa GeoNadir na nagsa-study ng seagrass. So, for that, kita mo yung mga seagrass, especially may technique dyan na you have para ma-capture mo yung detail nung flora and fauna underwater. So, wala naman akong drone na i-recommend, pero siguro lahat kasi ng DJI drones ngayon, meron naman yung GPS. Hindi sila lahat mapping drones, pero for mapping. Workshop yan kung paano siya gawin. So, kasi meron tayong mga drones talaga na mayroong mapping feature. The other drones, wala sila nun. Pero may hack pa dyan. May workaround dyan para magamit mo sila for mapping.
Okay. Thank you for that answer. Question po si Dr. De Los Angeles. Two additional question. Mention something solution or acquired data is recommended grid size for capturing ground data.
Apo, yes po, depende po yan. Kung ang objective ng study nyo is macro scale, so mas mataas po yung lipad nyo. So habang tumataas yung altitude ng drone natin, lumilit yung resolution nung image. So if your study calls for high resolution, you fly the drone lower. So mga 10 meters, 30 meters. Tapos po sa GeoNadir, once you upload your data, lalabas doon yung tinatawag nating ground sampling distance, yung distance between 2 pixels. So ang objective natin doon is habang bumababa yung lipad ng drone nyo, yung ground sampling distance nyo, lumiliit yon. So yung goal natin is mga 1 centimeter, sobrang ano na yun, or even GSD, sobrang detail na nun. Kasi ibig sabihin, pag zoom mo yun ng zoom, hanggang ma-reach mo yung pixel, ang pagitan ng dalawang pixels, yung centimeter na yon. So yun, so if you're looking for vegetation data, siguro magandang mas mababa yung ating lipad. Ang downside lang nun is matagal yung data collection. Kasi mas mababa, mas high resolution, mas matagal lilipad yung drone. Yun lang po.
Ayan, thank you. Again. Another question from Sir Leonardo. Advantages of GeoNadir processing software.
Nag-chat.
What are the advantages of GeoNadir over
ang advantage niya, especially sa akin, na before GeoNadir kasi, nag-use na ako ng drones for mapping. Pero I use several software. So meron akong software for stitching, tapos I use QGIS for georeferencing. Tapos yung storage pa, meron akong mga terabyte to store yung aking drone data. Ang GeoNadir solves all of those things. So, hindi mo na kailangan i-save yung images driver sa laptop mo. I-upload mo lang lahat sa cloud. And then, GeoNadir mag-stitch ng images for you. And then sila na yung magpa-process. So, ibig sabihin yung generation ng mga digital elevation models, sila na bahala doon. Hindi mo na kailangan third party na application. So, ang maganda din, compared sa ibang, actually wala pa akong nakikitang software na even comes close dun sa ginagawa ng GeoNadir. Kasi as of this moment, madami na ring GIS capabilities yung GeoNadir. Pwede ka nang mag-generate at mag-digitize ng elements sa GeoNadir mismo. So meron ka ng mga mapping features dun sa GeoNadir. So ang difference nito sa QGIS, kunyari, GeoNadir works with drone images. And unlike, hindi sila nag-work with satellite images. Pero may integration yung GeoNadir with GIS software na ginagamit natin. Ayun. So it saves space, time, processing power. Kasi usually yung stitching takes a lot of time. mga kalahating araw, especially kung thousands of photos. Pero GeoNadir, 1 hour, 2 hours, mapaprocess nila.
So, ayun. Efficient.
Efficient siya.
So,
Tsaka
thank
free.
you, sir. Oh, tsaka free.
Mm,
Ayun naman talaga yun eh. So,
yun yung
I think,
importante.
daw po, sabi ni Doc Mo. So, you mentioned that the software is capable of, generating EDM and TDM. Are these models accurate? Have you made validation through routing? In relation to training data, is there a minimum number of area? So, to allow generation of reliable training data.
Okay, yung sa mga elevation models, actually pwede nyo i-validate yan sa ano, sa mga elevation models derived from satellite. Pero sa GeoNadir kasi dun, sa satellite din naman nila dinederive yan eh. Ang downside lang dun sa elevation models ng GeoNadir, kita nyo kanina 'di ba may Viridis na color palette doon. Based lang yung color scheme dun sa specific data set na na-capture nyo. So kailangan nyo siyang ano, unlike yung mga nakukuha nating DM sa satellite image for the whole extent no nung area, kukunin nila yung elevation data doon. Doon sa GeoNadir, yun kung ano lang yung nakuha ng drone nyo. So ang ginagawa ko doon, kino-cross-check ko siya with the satellite-derived DEMs. Pwede rin kayo mag-ground truth, especially nire-recommend ko to sa pag kumukuha kayo ng heights ng trees. Kasi nagme-measure ang GeoNadir ng height, ng length, no, tsaka width. So maganda, pag pumunta kayo sa ground, tingnan nyo kung gaano ka-accurate yung measurement from the drone tsaka from the ground. Tapos from there, tingnan nyo yung error, no? Kung gaano kalaki. Tapos, in relation to training data, ayun kanina, pag nagka-classify, training data, mga 6 na points. So, kung familiar kayo na sa pagka-classify ng images, kumukuha tayo ng training data from the satellite image mismo. Sa GeoNadir, we get training data from the image. So ako, ng 6 or data, pero dinadamihan ko na. Pero merong isang magandang feature yung GeoNadir na I think wala sa QGIS. Meron silang training data for ano yung kailangan mo, tapos meron kang training data for ano yung hindi mo kailangan. So, symbolized siya by plus and minus signs. So, kunyari, I'm looking for vegetation. Maghahanap ako ng training data for vegetation. Lalabas yun as a plus. Tapos, yung nasa surroundings na hindi vegetation, lalabas yun as a minus. So, I think, ayun, magandang feature yun. Bago lang yun siguro last month lang siya lumabas. Ayun.
Alam mo, sir, sana mag-ano tayo, no? Webinar ng Miss lang. Para kasi nga
Oo
dami
nga.
questions talaga when it comes to, kasi syempre, ano na siya
Opo,
eh.
opo. Kulang.
Yan. So, last, sir, to ha, meron pang follow-up si sir.
Go
Ano nga
ahead
ba?
po.
Sir, si Sir Leo. Okay po ba ang PSD for forest mapping? Gumagalaw kasi ang hindi ba nabubuo ng maayos based ang photo sa stillness ng subject?
Opo, minsan nga po gumagalaw, especially no nakita ko yung sa data sets ng birds eh. Yung pag lumilipad yung mga birds. So, hindi naman po nagkakaroon ng distortion. Ang remedyo po dyan para mawala yung distortion is pag nag-mission planning sa drone, isang pasada lang po yan eh, pag automated. So, ang ginagawa ko, maraming passes. No? So, para matulungan yung AI mag-stitch. Oo, kasi meron kayong makikitang mga unting distortion, especially hangin. So, recommend na magpalipad ng drone if hindi masyadong malakas yung hangin. Siguro minimum per wind speed. So, wag po natin ipipilit na magpalipad ng masyadong maraming movement, especially movement na caused by wind para wala masyadong distortion. Pero so far po maganda yung nakukuha kong data pa, especially kung many passes. Siguro 2 passes yung ginagawa ko. Kaso po ang limitation po for that is yung battery life ng drone. Tsaka kung gaano kalaki yung study site. sa drone po, para lang may idea yung ating audience, no? Siguro yung 20 hectares kaya po ng isang 30-minute na battery. Depende sa hangin. Kung malakas yung hangin, mababawasan pa po yun.
So, I hope nasagot lahat ang ating mga questions ni Yes.
Thank you po.
So, limited time. So I think yun na po ang lahat. Ayan. So thank you very much for that very engaging and lively discussion, Jabez. So let me now proceed with the presentation of our certificate. Let me just read the citation po. So University of the Philippines, Los Baños, Certificate of Appreciation to Dr. Jabez Joshua M. Flores for serving as the resource speaker during the webinar entitled Drone Mapping, Potential Applications of GeoNadir Environmental Software in Forest over Limestone Research of the Kaigangan Biodiversity Webinar Series, held on 4/24 via Zoom. So signed, our project leader, Marie and Banatik. Again, thank you always, Sir Jabez, for accepting our
Thank you po, ma'am.
yes, yay. Thank you. Let's all send
Thank you.
Jabez a heart reacts. Thank you, sir. And for our next webinar po, this is on December 2, 9 a.m. still, but so it is with Margie Hennes, so instructor of Caraga State University. And it is about priority conservation in Summer Island Natural Park Forest over Limestone, the Philippines, using a localized conservation. Ayan. So I hope makita-kita po ulit tayo next webinar on December 2. So registration, you can scan the QR at your screen po. Ayan. Pwede po yung mga naandito sa ating Zoom ay kikibuksan ang ating camera. Photo. Again, and always attend.
Thanks po. Daming umatenda. Salamat.
Okay. So I hope open na po ang camera ng lahat. If not, you can click the react button so we know that you are present and attentive po sa ating webinar. Okay. So smile lang po everyone. 1, 2, 3, smile. Save ko lang po. And then another slide po. We have 3 slides. More. 1, 2, 3. Smile. Okay. For the last slide po natin. Smile po. Okay, thank you very much po.
Ayan, thank you very much po again. Thank you very much. Before you leave, please do not forget your code. Flash po sa ating screen. The form or link will be put in the chat box. So, thank you everyone. See you on our next webinar for the rest of the day po.
Thank you po.
Thank you.
Thank you very much po, Doc Jabez.
Samar Island is the third largest island in the Philippines and has one of the most extensive forest over limestone ecosystems in the country. This ecosystem is home to a wide array of uniquely adapted flora and fauna. Samar Island is known to be one of the centers of botanical diversity in the Philippines and has been nominated as a UNESCO World Natural Heritage Site for its exceptional natural beauty and precious biodiversity. For these reasons, CONserve-KAIGANGAN, a biodiversity research program, was established. Kaigangan is a Samar local word that means forest over limestone. Our research program's mission is to assess and conserve the biodiversity in Samar Island's forest over limestone towards its sustainable management. One of our program's projects is the assessment of biodiversity and community structure in forest over limestone ecosystems. This component of our research aims to determine plant diversity and vegetation structure in various habitat types in forests over limestone, to determine animal diversity associated with forest over limestone, to identify functional classification of vegetation with its associated animal diversity, and to analyze the environmental factors influencing the prevailing structure of the biota. We conducted a comprehensive biodiversity assessment of forests over limestone in the municipalities of Paranas, Taft, and Giwan with remarkable findings. A combined total of 71 plant species were recorded from these municipalities, with at least 3 tree species classified as vulnerable based on the DENR updated national list of threatened Philippine plants. A total of 52 terrestrial vertebrate animal species were also recorded, including 5 amphibian species, 15 reptile species, 20 bird species, and 12 mammal species, with conservation statuses ranging from threatened to endangered and critically endangered, based on the DENR updated national list of threatened Philippine fauna. This knowledge will empower our stakeholders in these areas to make appropriate research-based conservation efforts for the protection of these ecosystems that harbor an assemblage of rare, endemic, and economically important flora and fauna. Through this program, people will be equipped with knowledge on forests over limestone biodiversity, including the ecosystem services that it can offer to the community. We at CONserve-KAIGANGAN continue to further raise awareness and capacitate national and local government agencies, especially local communities living in and around Samar's Kaigangan.